Okay, it's recording now. Now, a woman at an airport is towing her 20-kilogram suitcase at a constant speed by pulling on a strap at angles above the horizontal. The pulls on a strap with 35 Newton force. The kinetic frictional force on the suitcase 20 Newton. What the free body diagram? Okay, first of all, I want to draw a free body diagram briefly at the diagram here. So here we have, it's given all the forces, okay, the F and kinetic friction, which is this one is Fk, okay, so it's given given the mass of the suitcase. So we already have the F here, friction, okay, friction, and then we have the weight, and then we have the normal force. So our free body diagram we draw as a point mass. Remember, point mass. Alright, so let me draw it. Point mass. So use pencil. Yeah, when draw, use pencil. The force you can use pen, but it's recommended if you are use pencil yeah, you can still rub off. If you use pen then it's permanent. So okay, draw a point mass there first. Just a point mass only, just a point mass. So then and then this is angle degree, and then this friction. This is the weight. The weight equal to mg, and then you have the normal force. And then because this is chapter 3. You must draw acceleration, but this one constant speed. This one is constant speed. Okay, constant speed. So this one acceleration 0. You must write acceleration 0 at the side. Yeah, acceleration 0. Okay, acceleration 0. Constant speed. Yeah, means acceleration 0. Or the other words we can say is equilibrium. Equilibrium. When we talk about equilibrium, that means total F is 0, total Fx 0, Fy 0. Yeah. Okay. So when equilibrium, that means no acceleration to follow. Yeah, no acceleration to follow. We just take direction to the right, positive, direction to the left, negative, upward positive, downward negative. Okay. That's your free body diagram. Okay, complete. Now, what's the angles? The strap. So, I want to find this angle theta. Okay. So, how are we going to do this? Okay, so we continue. Question B. So, we need to do XY component lah. Understand? You need to do XY component. Okay, you need to adjust it a little bit here. Okay. XY. Is it too small for you? Can you see the things here?
Yes.
Boleh lah. It's better if you use a PC, a laptop there. Yeah. Then it's bigger screen. Yeah, bigger screen for you. Okay, so X and Y component. So we know this equilibrium. So total Fx is 0, total Fy 0, everything 0. So going put direction to the right positive, direction left negative. So this one you need to resolve first. You want to do components, you need to resolve. Yeah, you need to resolve. So here we have F cos theta, and here we have F sin theta. Okay. F cos, F sin. Okay. If better, your free body diagram draw big. Draw the don't save your paper. Yeah, paper is given by the examiner. Paper is given by the college. Use as many paper as you can. Draw the diagram bigger so that easy for you to put in extra information like components, or if you draw your free body diagram too small. Then everything is jumbled up and very hard to distinguish all the details. Understand? So draw your free body diagram as large as possible. Yeah, across the whole paper, if you can, across the whole width of the paper. So it easy for you to add more details. Okay. So now, Okay, so x component is only F cos theta and friction. Very simple. So F cos theta is positive and friction is negative because direction to the left. Okay, and then how about y component? Going up positive, going down negative. So n plus f sine theta and then negative mg 0. Okay, very easy. So put in all the information. We have 35 Newton and then friction. Okay, just put in everything there. 35 cos theta and then negative friction. Friction is 20 Newton. Okay, and okay, so I think no need to do the normal force also because friction directly given unless it give you the mu, isn't it? Unless it give you the mu k, unless it give you only the coefficient of friction, then you need to find the normal force some more to get the friction. Now he directly give you the friction. That means no need to consider the normal force. Actually, you no need to do normal y component. So this part you can actually no need to do lah. Yeah. So, unless he give you only the coefficient. This question is easy because he directly give you the whole friction. Yeah. No need for you to find the mu kn. Okay, so no need to do y component, just do x component. You can find theta already. So okay, so make sure your calculator you set to degree, class. Not radian, degree, all these thing, all these details, I hope that you're not careless, Okay, so okay, so what is the theta? So 20 over 35. Okay, and then anti-cos answer. So that's the okay. I got 55.15 degree. Okay, is above the positive axis. Yeah, above positive axis. When direction, I always write to write the some wording here to explain more detail. Yeah. So that's the angle, and then how about C? What is the magnitude of normal force? Okay, it seems that we need to do the y component also because the question asks for it. Yeah, ask for the normal force. So we need to do the normal force. Okay, so ask for the normal force. So okay, so just put in all the values. Force is 35 Newton. I got the angle just now, which is 55.15 degree. And then minus, what is the mass? Mass is 20 kilogram. Okay, very easy. 29.81 equal to 0. And then you also mathematics. Okay, 20 times 9.81. Okay, and then minus the 35 sine 55.15. So the answer is 167.48 Newton. So that's the answer. Okay, let me check the answer. Is it correct? Let me check the answer. Is it correct? Where is it? Okay. So you see just now my free body diagram. All correct, right? That's the way. All correct, 3 marks. And then how about angles? 55.18. Yeah, 55.15. It's okay. You can still accept it because this my answer is not round up. No, the answer is round up already. Yeah, so that's why a bit different. Okay, and then normal force is 167.147. 167.4748. Okay. Okay, so it's correct. Okay, that's the way lah. And then how about the next questions? Understand, class? So okay. Yeah. So how about the next question? Let's check the next questions. Wait. Let me wait. Okay, the next question is this one. We'll screenshot this one. These questions and this one. So I will put it over here. I want to do comparison between these two. I want to do comparison. Yeah, sometimes you didn't teach it side by side, you very hard to see. Now I want to show the difference between chapter 3 and chapter 4. Okay, so let us start discussing this question. I'm still recording. Yeah, I'm still recording. Okay, now a horizontal force of 150 Newton is used to push a 40 kilogram packing crate at a distance of 6 meters at the rough horizontal surface. If the crate moves at constant speed, find the work done by a frictional force. Okay, you still have to draw free body diagram for this. First, draw your rough idea. Yeah, draw your rough idea. So, what's the draw a comic? Yeah, draw a comic here. Yeah, what's happening? There's a crate. A horizontal force is horizontal, no angle. Yeah, no angle. So that means it's just horizontal force. You know, pushing this crate across a distance of 6 meter. Okay, and rough horizontal surface. This surface is horizontal, not inclined. Yeah, this question will be easy. Yeah, rough, that means has friction. So this block is sliding across, so it's kinetic friction. So it should be opposite. The friction should be opposite the motion, right? So should be going backwards. So okay, all right. I need to okay. So friction, I has friction, and it is constant speed. Okay, I will talk about constant speed later on. Okay, we want to find the work done by frictional force. So okay, this is the weight and of course the normal force. Understand, class? So okay, constant speed. So one thing we know about constant speed again. One thing we know about constant speed is again acceleration 0. These are keyword, very important keywords. You must look for this word constant speed. Acceleration 0. One thing we know is acceleration 0 and then total force is 0, isn't it? The other thing we know it is the net work done is also 0. Understand? Because why? Velocity constant, acceleration 0, velocity constant. That means the kinetic energy also constant. Understand? We can say the kinetic energy also constant. Kinetic energy also constant. Okay, kinetic energy constant. So is there any change of kinetic energy? Change of kinetic energy should be 0 lah. Understand? The final kinetic minus initial kinetic is 0. The final kinetic actually equal to initial kinetic. You understand or not? Because no change in kinetic energy constant. So that means the net force is 0. Understand? Can write resultant force or net force equal to 0. So we know that work energy theorem. Yeah, the work energy theorem. What is work energy theorem? Net work done equal to change of kinetic energy. Understand? Change of kinetic energy. So change of kinetic energy is 0. Now the net work done is 0. Change of kinetic energy is 0. The final kinetic equal to initial kinetic. One more thing, we can know that the net work done is actually net force dot displacement. Understand or not? Net force dot displacement. So net force times displacement cosine theta. Just now we also know net force is 0, right or not? Net force is 0. Net force 0. That means the net work done is 0. Correct or not? 0 multiply displacement, so 0 lah. So there's many angles we can see from here. Understand? Understand everything I'm sharing over here? Understand?
Yes, sir.
Everything is laid. Yeah. Everything is laid out here. Everything here. Yeah. All the concept. So the net force is 0. So no. So that's for only one word. One word of constant speed, and it carries so much weight. It carries so much. I can say this is a very deep meaning word. Okay. Which have a deep concept. Everything is here. Okay, so now based on using all this knowledge, we try to solve the question. Work should be easy already. Yeah, if we know all this. Yeah. So work done by frictional force. So the question asks for. Let me highlight first. Work done by frictional force. That means you work done by friction. Work done by friction. Okay. So how? Actually, there are many ways to do this question. There are actually two ways to do this. You can either go back to chapter 3. Go back to chapter 3 using the net force equal to 0. Net force equal to 0. And then you can also find the frictional force first. Then you find work done by friction. Or you can also use the work energy theorem to solve the question also. Yeah, use the net work done equal to 0 kinetic energy. Then you find work done by each forces. You know. Then you also can find work done by frictional force. So there are two ways to do this question. Yeah, you can use the first way over here, or you can use the second way over here. You use the net force or equal to 0, or you use the net work done equal to 0. Which one? Actually, just now the previous example already show you the first way, right? So I don't want to show you this one. Yeah, so for this one I show you the second way. Yeah, net work done. Okay. I don't know which. Actually, both way is easy lah. Yeah. Okay, so let's draw the draw again the free body diagram. Yeah. Free body diagram is a dot only. Yeah. Free body diagram. Let's draw the free body diagram. So free body diagram, so it's just a dot. Okay, so draw all the forces. So you have the force F here, you have the friction, you have the the weight we put as gravitational force lah. Yeah, we don't want to mix up W with work done. Understand? We put as gravitational force, and then normal force. Okay, and then for this chapter about work done, because you are using work done, so better you draw displacement. Understand? Draw displacement. Because we want to compare, we want to get the angle, theta. Yeah, because Fs cos theta. We want to get the angle theta. Yeah, we draw displacement. Okay. So now, how are you going to do this? Yeah, I want to use the work energy theorem. We know that this one is constant speed. Constant speed, that means net work done equal to 0. Yeah. This one is V constant. So work energy theorem, we know that net work done equal to 0. Okay. Wait first. Net work done equal to change of kinetic energy equal to 0. Understand? Okay. So find work done by each forces. Yeah, work done by each forces. So work done by force F. Work done by force F is Fs cos theta. Okay. Do I have the force F ready? Yeah, I already have the F already. 150 Newton. This is the mass, and this is the displacement. Okay. So So 150 and okay. So just now the force is 150 Newton. 150, and then displacement is 6 meter. Yeah, 6 meter. Cosine, what angle, class? What angle? What angle between F and S? 0 degree. Yeah, 0 degree. Okay, so it is 150 multiply 6. Cosine 0 is 1, isn't it? So this is positive 900 joule. And then how about the work done by friction? Class, work done by friction. Is using friction as cosine theta. Okay, the question asks for what? Work done by friction. So actually no need to find friction, yeah, unless so actually actually no need to do lah. This part we want to find the work done by friction. So I can straight away continue from this one, work energy theorem. Okay, net work done because it's zero lah, yeah, because constant speed, right? Okay, so network done is work done by normal, work done, okay, add up everything. Work done by force F, work done by friction, work done by normal force, work done by gravity equal to 0. Okay, work done by normal and gravity is 0, isn't it? You understand why 0, class? You know why work done by normal force is 0? Yes, because they are cos 90 degree. Correct or not? Cos 90 equal to 0. This one is gravitational force, which is you know, mg multiply s cosine 90 also. Cos 90 also. So they are 0. So that means 0, 0. Okay, class? Okay. So 0. So it's only work done by force and friction. Very easy. So this is 900 plus work done by friction equal to 0. So work done by friction is negative 900. We got it. If you want to find the frictional force, later you equal this Fs friction S cos theta equal to negative 900. Then you can find the frictional force. Understand? This theta is 100 cos 180. Yeah, it's cos 180 because you know the friction and displacement are opposite direction. Understand, class?
Yes, sir.
Yes.
So, if the other way around you want to do it, you also can. You know, you find the total fx equal to 0 kan? Yeah, based on the first method, you also can you know, total fx equal to 0. I show you lah. Never mind. Yeah, I show you. So we based on chapter 3 formula. So you know. You can put it direction going to the, you know, going to the right, because acceleration 0, yeah, as negative, this one positive, this one negative. So that means you can say you know, F negative friction equal to 0. So what is the friction force? Okay, force F is 150, yeah, 150. So it's 150 minus friction equal to 0. So friction equal to this one go the other side, negative 150, so it's 150 Newton. Okay, so later we find, you know, work done by friction, add friction S cosine 180, isn't it? Because it's you know, friction and displacement opposite direction, so it's negative cos 180. Cos 180 is negative 1, and then friction just now you got is what, 150 multiply S. What is the S? S is 6 meter. 6 meter, and then negative 1. So you get what answer? Negative 900 joule. So you see, it's the same. You see that this is second method, yeah. This is the second method, and this is the first method. So which either one also can lah, yeah. Either one also can. Which one easy you just choose lah. Understand, class? Sometimes the question you can only do using the first method. Sometimes you can only do using the second method. Yeah. So it depends on the type of question. Yeah, sometimes you cannot do using the second method. You must do using the first method. And vice versa lah. Depend on the question lah. Okay, but there are two methods I want to tell you. Yeah. Okay, class.
Okay, sir.
Okay, so they are the same concept. Okay, that's finished for this question.